7. Taking force, length and time to be fundamental quantities, find the dimensions of. Let's start with the density. So if we write density as D is written as mass per unit volume. So I can write it as mass L to the power of minus 3. And this we need to express it in terms of force, length and time. So let us say we have force, length and time. These are the three fundamental quantities. So let us say their dimensions are A, B and C. We need to find out this A, B and C. So what we do is we use this equation that will give us three equations, and we should hopefully be able to solve and find the values of A, B and C. So first of all, we need to express this force F in terms of M, L and T. L and T, these two are already known. So we write it as M L to the power minus 3 is equal to force is mass into acceleration. So M L T to the power minus 2 whole thing to the power of A multiplied by L to the power of B multiplied by C to the T to the power C. Now we can equate all the M, L and C's and find out the values of these three constants. So here M to the power is 1, so 1 is equal to, here M to the power is M to the power A here, so that gives us A. Now let's look at L. L to the power is minus 3 here. This is equal to L to the power A here and L to the power B here. So A plus B is minus 3. This implies B is equal to, if you write A equal to here and take a 1 here, so that will be equal to minus 4. And finally T to the power is 0 here, so 0 is equal to T to the power is minus 2A here and T to the power C is here plus C here. This implies, now we substitute value of A here. A is 1, so 2 minus 2 here, so C is equal to 2. So in that means the density can be expressed as, going back to our original this thing expression here, density is force to the power A. So force is F, we have A as 1, so force to the power 1 multiplied by length to the power of minus B, B is F minus 4, and then time is equal to, T is equal to the power of C or 2. Let's compare our answer here. Question number C, the answer says F L to the power minus 4, T to the power 2. So our answer is good. Let's move on to the next one. So we can similarly do all other problems. I'm doing it for 2, but hopefully you should be able to do these problems yourself. Problem number, we need to find out the pressure. So what we do, this is problem number B. We need to express pressure. Pressure is force divided by area, force acting on per unit area, or force is mass into acceleration L T to the power minus 2 divided by L square, or we can write it as M L to the power minus 1 T to the power minus 2. So we need to write this thing M L to the power minus 1 T to the power minus 2 in terms for force to the power A, length to the power B and C to the power time to the power C. Now what is the equation? A is equal to 1 from so force is expressed as M L T to the power minus 2 to the power of A into L to the power B C T to the power C is equal to M L to the power minus 1 T to the power minus 2. Now equate the powers of M becomes A is equal to M to the power 1. L here, L to the power this A plus B, so A plus B is equal to L to the power minus 1 is minus 1 here, so A is 1, so B is equal to minus 2. And now finally T to the power minus 2 here is equal to T to the power minus 2A plus C here. This implies A is equal to 1, so minus 2 cancels, C is equal to 0. So our pressure can be expressed as this force to the power A is 1, so F to the power 1 multiplied by L to the power B is minus 2, L to the power minus 2 and T to the power 0. Let's check our answer. Question number 3 is FL to the power minus 2, FL to the power minus 2. So our answer is correct. Let's move on to the part number C. C says momentum is defined as momentum is mass into velocity, mvml t to the power minus 1. This is our momentum, and momentum we need to be equal to 4 to the power a, length to the power b, and time to the power c, and f we carrying as ml mass into acceleration, ml t to the power minus 2 whole to the power a, l to the power b, t to the power c is equal to ml t to the power minus 1. Equate m's coefficient, m's power, m to the power a is a here, m equal to 1 here, so a is equal to 1. Now l to the power is 1 here, and l to the power is l to the power a here, and plus l to the power b, a plus b, so this implies b is equal to 0. Now t to the power minus 1 here is equal to t to the power minus 2a, and then plus c. This implies a is 1, so this is 1 minus 2 goes here, 2 plus 2 minus 1 is 1, so c is equal to 1. So the momentum can be expressed as force to the power f to the power 1, l to the power of b is 0, and t to the power of c is 1. So f to the power 1, t to the power 1. Let's check our answer. Question number C, this is f into t, so that is f into t. Our question answer is correct. Question number finally part D, is we need to find out the energy. So energy is expressed as force into distance, or force is ml t to the power minus 2 multiplied by distance is 2l square, and that we are expressing as f to the power a, l to the power b, t to the power c, and f is ml t to the power minus 2 mass into acceleration to the power a, l to the power b, t to the power c. This is equal to m l square t to the power minus 2. Equate the coefficients, m to the power a here, so a is equal to 1, l equate coefficients of l is square, so 2 here, l here is l to the power a plus b, a plus b is equal to a is 1, so b is equal to 1, and finally t to the power minus 2 here, and here t to the power is minus 2a, and then plus c. This implies c is equal to, now substitute a is equal to 1, minus 2 cancel, c is equal to 0. So the energy can be energy dimension formula can be expressed as f to the power a, which is 1, l to the power b, which is 1, and t to the power 0, or f into l. Let us check our answer finally again one more time. Chapter 1, f into l. Our answer is correct. Hopefully you also get the answers correct and you know the method.